confused.
I'm so confused.
Sounds like you guys need to read this.
Oh, thanks. Oh, history of the atom.
Atoms are the smallest unit of ordinary matter that forms a chemical element.
In ancient Greece, they proposed that all matter was made up of indivisible particles. Since ancient Greece, the atom has come a long way. Let's look inside.
Whoa, where are we?
Hello?
Who's that?
I'm John Dalton. Put some respect on my name. Let me tell you about atomic theory. I am John Dalton. I was born in 1766 and I attended college at New College. I taught math there, but you probably know me as the father of the atom. I formed the modern day atomic theory.
Hadn't the Greeks already studied atoms?
Well, yes, the Greeks had theorized the existence of the atom, but I was able to prove it existed.
How did you prove they existed?
I used gases and compounds to prove they existed. I found that gases consisted of small particles in constant motion. These particles were atoms, and I also used compounds to find this out. I found that compounds have their own unique ratio of different elements, which made them the compound. And the only way this would happen is if elements were composed of indivisible particles. These particles are atoms.
What were you able to prove?
I was able to prove that atoms are the smallest unit of matter. They are indestructible, cannot be divided or created. Atoms of the same element have the same mass, and atoms can join to form compounds in their own unique ratio. I formed the billiard ball model of the atom, in which the atom is a wooden sphere.
Why is this model a solid sphere?
Because atoms are indestructible and indivisible, and they are uniform throughout. There are holes in the wooden sphere in which hooks can combine the atoms to create compounds. Thank you, ladies.
Wow, that was so cool.
I know, but I'm still so confused.
I know, same. Let's see what this guy does. Whoa.
That must be J.J. Thompson.
Hello, ladies. Let me tell you about my atomic theory. My name is J.J. Thompson, born in 1856, and I attended Trinity College at Cambridge University. You may know me as the father of the electron, which are negatively charged particles in an atom.
Well, Dalton told us that atoms were the smallest particle.
Well, that's what he thought, but that's actually not true at all. So basically, I used cathode ray tubes to discover electrons. I put two oppositely charged electric plates around a cathode ray. The cathode ray actually deflected from the negatively charged plate, and it went to the positively charged plate. This showed that the cathode had negatively charged particles because it deflected the negative plate. Every time I did this experiment, the same thing happened. I was perplexed. Before, Dalton thought atoms were the smallest unit of matter. But I actually discovered subatomic particles, and I discovered the electron exists. And I was able to discover that the electron has a negative charge inside of the atom.
Do atoms only have negatively charged subatomic particles?
Well, no. Since the atom's charge is neutral, there has to be a positive charge to cancel out the negative charge of the electron. I deduced that electrons are floating in a sea of positively charged particles which cancel out the charge of the electrons. I made the plum pudding model.
That's a weird name for an atomic model.
I get it might be a little strange, but it resembles an English dessert called plum pudding. And all the electrons are floating around in the sea of positive charge. Thank you so much, ladies.
I guess that makes more sense.
Yeah, but let's find out more. Hey, it's Ernest.
That's Mr. Rutherford to you. Let me tell you about atomic theory. I was born in 1871. I studied at Canterbury College in New Zealand. I'm the father of the nucleus, and I discovered the nucleus, which is a positively charged center of the atom.
Isn't there a sea of positively charged atoms?
That's what Thomson had previously thought, but it is not true. I used the gold foil experiment to discover the nucleus. Basically, I bombarded thin sheets of gold foil with positively charged alpha particles. Scientists expected the particles to pass through the gold foil, but actually some of the particles deflected. I was so perplexed. How could this happen? It was totally bonkers.
Why was this so crazy?
Because alpha particles would require an insane amount of force to deflect off of the gold sheet. A huge amount of force, in fact. So I deduced that the positive charge had to be super concentrated in the center of the atom in order for there to be enough force to deflect the gold sheet. Because most of the alpha particles did pass through the gold sheet, I found that most of the atom is empty space.
How much of the atom is empty space?
So much of the atom is empty space. Practically the entire atom is empty space, and there is just a tiny, tiny, tiny nucleus in the center. Protons and neutrons are in the nucleus, and the nucleus has a positive charge. Most of the mass of the atom lies in the nucleus. I created the nuclear model in which electrons surround the tiny, tiny nucleus.
Who's next? This Bohr guy. Wait, I think I remember Booth talking about him in class today.
Wake up, ladies! My name is Niels Bohr. I was born in 1885 and I studied at Copenhagen University. I am the father of the electron shell, and I found that electrons exist on orbital shells. When electrons drop energy levels, they emit light.
How were you able to find this out?
Originally, I worked with Thomson and Rutherford, but their atomic models were highly inaccurate in my mind. So, I proposed a theory for hydrogen atoms, that electrons move around the nucleus in orbital shells. I have a good friend named Planck, who's a great quantum mechanic chemist, and he made Planck's constant. Using this constant, I found an accurate formula for energy levels.
Wait, how do atoms emit light? I don't get it.
So basically, when an atom absorbs energy, electrons jump up in energy levels, and then when they release this energy, they drop down in energy levels as they release the energy.
So, what does this atom look like?
Let me show you. Here is the nucleus, and here are the electrons. The electrons move in orbital shells around the nucleus. Thank you, ladies.
All this time traveling is making me exhausted.
I know, but we have to keep going.
Hello, ladies. Wake up, wake up. My name's Erwin Schrödinger. Oh, I was born in 1887 and I studied at the University of Vienna. I am known as the father of quantum mechanics, and I was able to disprove Bohr's atomic model with electron shells.
How did you disprove electron shells?
I basically used math equations to describe the likelihood of finding an electron in a certain position. From this, I formed the quantum mechanical model of the atom. I used Heisenberg's uncertainty principle, which basically told me that you cannot know the exact location of an electron. Although you cannot know the exact location of an electron, there is a way to understand the general area of an electron.
How do you find the general area of an electron?
You find where the electron lies through sub-energy levels. These are energies associated with electrons, and electrons fall in different levels depending on how far they are from the nucleus.
So what are the sublevels?
Well, there's S, P, D, and F. In my quantum mechanical model of the atom, electrons do not follow an exact path like in the Bohr model of the atom. Instead, they fall in sub-energy levels within their shell. Here is the quantum mechanical model of the atom. He is the nucleus, and he are the subshells. Thank you for your time, ladies. Thank you, thank you, thank you.
That makes so much more sense now.
Yeah, but you know what was weird? All the scientists had the same hair.